So I'm a researcher also from the Center of Ecology. So my research background is mainly biological assessment. I work mainly on the field, doing monitoring work, collecting mainly aquatic invertebrates. But later I was involved in the national assessment to make this ecological quality ratio for Hungary, to developing the assessment systems and not only for the aquatic macroinvertebrates, but also for phytoplankton and diatoms and all of these biological elements which are involved in this water framework directive. And now in my talk I would like to speak about this European freshwater biodiversity loss and what cause is the halt. So my main presentation is based on a recent article which was published in Nature with a lot of co-authors. The main purpose of this article was to give a very strong evidence for the decision makers of Europe that biodiversity is not in a good shape and we need to prove more effort. So the main message was that the European legislative measures can promote recovery in freshwater ecosystems, but we need to work more and we need to add more measures to increase the biodiversity. So just about the articles and its press present, it was from a scientific point of view, it was a very successful article. It got a lot of news, including it was in the press a lot of times, and even our lead author won this Nature Prize or the Frontiers Planet Prize in this year. So as a research article, it was successful. And now let's see whether it can be successful on an EU level and on the decision-making level. So first, we collect a large amount of data, much more data which were included in the Water Framework Directive. And this data comes from individual researchers, from monitoring and from monitoring agencies. With a lot of countries involved, more than 22 countries, and we collected more than 26,000 data. Although the mitigation measures show some improvement, yes, but we need urgent evidence for further mitigation measures. But first, let's see our main targets. These are these aquatic macroinvertebrates. You maybe already know them. These are the dragonflies, mayflies, aquatic coleopteras, and mussels and leeches, and aquatic bugs also. So these was our target group, and the reason is why that these are well-known organisms, and in most of the countries in Europe there was long-term monitoring sites and more data were available. The other biological element which could reach this number of sites may be the fish. But for instance, for phytoplankton or the diatoms, we don't have so many consecutive data sets. So, and how to quantify this biodiversity? So the most easiest biodiversity measures is the taxon richness, number of taxa, which can be found on the sides. So in this case, if you count this number is 14. And we can also use other metrics, such as the functional richness. Each of these species or this taxa has some function. For instance, they are predators, so they eat other animals, or like the odonats or the water bugs. This is the water bugs, or they are grazers, so eating biofilms and diatoms, such as the snails. And from this perspective, we can count the functional richness of this samples, and we get, for instance, 2 for this functional richness. So we have other more complicated measures, but these are the most easiest one. So again, the data set, as I mentioned, it was almost 100 researchers were involved. And this is why it gives us a very big evidence of our research. About the timeline, we collected long-term data sets. Long-term means more than 80 years of data. All this data set was 20 years or more, and it's cover almost the full timeline of the European waters. So you can see that after the World War II, there was a big acceleration of industry, and we almost completely lost every biodiversity in almost all Europe. In Germany, Netherlands, Belgium, or France, and even in Hungary. Then we have this acidification, and then we start to work more on to improve our waters. So in the 80s, there was the urban wastewater directive, and in most countries, Europe start to improve the wastewater treatment plants. And then in 2000, the EU Water Framework Directives comes into the legislation, and this gives a big boost, at least in the northern part of Europe and in the Baltic. Hungary, we joined the EU somewhere here, and we started monitoring in 2007. So we have data from 2007 only. But how to compare the biodiversity on larger scale? It was a very difficult task because in every country the researchers are different, the taxonomic expertise are different, we differently identify the taxons, we differently making the samples. Somebody use net, somebody use other devices to collect, so it was difficult. And each of the sites we have some taxonomic list, but how to compare. So for instance, if you just use the taxon number, what I said about how many taxon we found on a site, you can see that, for instance, Hungary is more diverse than Germany because we have more taxonomic data, so it's not easy to compare this. What we compare, we can compare the trends. If it increases here and here, then we can say that the trends are similar. Or if there is a decrease here or increase, so we can compare trends. Then, if we can compare trends, it is universal for all Europe, and we can apply it for every site. So we calculate for all these 2,000 sites, for each site the trends, and we can see that on a global pictures there was an increase in the biodiversity at the whole timeline. So it means, for instance, in the recent 10 years. And we can produce very beautiful maps. I will not go into the details, but we can calculate a lot of biodiversity measures, and we can show this improvement of biodiversity to a long time gradient. But if we see it in more details, how these trends are changing to the time, we can see that there is some problems. This blue area means the positive trends in which there is an increase in the biodiversity, and in the red line you can see that there is a decrease in the biodiversity trends. So it means that the sites become less and less diverse. And you can see that from 2010, where most of the sites were in the positive trends, it turns down, and in recent years we don't see any improvement in the quality or in the biodiversity. And this was our main message, that this should be something to done with this graph. And of course, this decline was seen in the Hungarian data set, also in all other data set. If we put it together on the European scale, this is the scale when the decision makers could hear our voice. So in the beginning of the European Water Framework Directive, we have an uprising trend, so we were very happy. And it seems that the European Water Framework Directive gives a really big boost in the diversity increase. But you see that in these years this is not the case. And then we try to find what caused this decline. And as I said, it's not only European scale, but also it's very visible in, for instance, in Belgium and even in Hungary. We have a very sharp decrease in the quality after 2010. So what caused this decline? We make a lot of statistical calculation. I will not make into the details, but the main message was that sites which has a dam on the river, or which has a large urban area or a large croplands, these all negatively affect the diversity change. So those sites which has a lot of agricultural pressure, a lot of hydromorphological pressure, and also we can say that even if the temperature is higher, then it caused a decline in biodiversity. So it was also strong evidence, and for European scale was So we have three more targets which could highlight it. These were the emerging new pollutants, because after 2010 there were new pollutants occurring in the rivers. The other was the land use, and the climate change could also cause this. These are some predictions from our data, and you can see, for instance, this is Hungary. So it means that in the prediction we will lose all of our diversity. Of course, this is not true, but the prediction is really threatening us. So emerging pollutants, like we heard in the previous presentation, like the microplastic and other things, pesticides and so on. The problem is that the monitoring network is very limited. This is the EAA dataset, and you can see that in some countries or in some areas we have very large coverage of this monitoring, but for instance we don't have data from Spain, Portugal, and even not from Hungary, Romania, and Poland. So very few data points. Mainly countries which are more rich or more money, they can afford this monitoring system. But for instance, in Hungary, the monitoring system is decreasing for this new pollutant. So I don't know where we get data in the future. So more monitoring needs. For the agriculture, we also make some paper and try to model what will be the future. And we find that even in case of significant agriculture reduction, that will be not improve the good ecological status. And you can see on this map that the good ecological status is not reached and will be not possible to reach until 2027, which is the end of the Water Framework Directive. And this calls for additional measures, legislative regulation, and other things to do. And for instance, if you clear our water, it's also important where to put it. So if we put it like here, between the concrete dams, it will not improve the biodiversity. So we need to restore this kind of things. So the clean water alone is not enough. And we need to improve our water basin management plan also. And now for the climate change, if we go back to the timeline of our articles, you see that in Hungary, for instance, every warming will increase, number of hot days will increase, the number of rainy days will decrease. And this is just an example of a simulated drainage area of a river. As you see, the worst scenario is the gray one, is this light gray. This is the optimum scenario of the climate change, and the red line is the actual scenario. So you can 5 minutes, okay. So you can see that we are far in the worst scenarios, and till August, almost 70% of the catchment is already dry. And in our timeline, we finished 2021, and the hottest summer is 2024, and so, and the next summer will be also the hottest European summer. So we don't see the end of this. And why is it important? Because the nature can adapt, but the nature cannot adapt for too much fluctuation and for the chaos. For instance, in our case, even a permanent timber could make good knowledge what to do, but if they get some dryness period, that we will not know how to work with these things. Because our Water Framework Directive based on the EQI and the reference sites, and this is a reference sites. You can see if they have water flow, it is stable. But if they don't have enough water flow, it tries to fluctuate. And this is on the same catchment. So and it's the same reference sites. So if our reference sites start to moving, then maybe all of the water framework quality assessment will collapse. So the take-home message as an EU level, that the legislation and long-term vision works. So I think the Water Framework Directive was a good one, and it works in the beginning, but now maybe it's a bit run out of fuel. For the member state, what is needed is monitor and mitigate. So if they make good measures, the nature will give us a good response. So the diversity will increase if we make good measures. If we make bad measures, if we make concrete, that we will lose everything. And on the citizen level, the most important is the education and to put pressures on the decision makers. So this could be our key take-home message based on this presentation. And thank you for your attention.